So we have something going on here. My batteries were like 77% yesterday. We had a lot of sun today and came in and they were at 54, but my wife, when we just filled up our deep freezer, clogged the vent, and she turned it on high. We cleaned out it, made some space, put it on high, and I'm trying to justify where's the extra power going. The 77% down to 54%. Mind you, I have three 200 amp hour batteries, so it should, you're roughly looking at 300 watts per percentage. I'm like, that's just way too much. But I said, you know what, screw it. We were in the middle of doing something else. So we go do something for about 2 hours and come back, and now 57, 53, whatever it was, is down at 44%. I'm like, that's way too much wattage to lose. So as I'm running these lines down, I was testing the ends of those lines down there, and I'm getting 15 volts. I called my electrician hookup, and he says, yeah, you typically get, get some cross feed and everything. He goes, 15 seems a little high. He goes, have you ran the ground to your breaker box? I'm like, no, not yet. This was yesterday before we figured out this battery loss today. So I hooked up the ground from the box going outside to the ground, and then I went down there and tested. Like these 4 wires, the breakers are off. There's only one, because this breaker box is basically set up down there. I only have one line out of these 4 that come down. I still have to run more, but they come down here. And because we've been super busy, instead of hooking each individual line up, they're just sitting right there on the ground. I just wire tied one, and all the breakers were here. I pulled them out. I just wire tied them all together, because really the only thing that we have going on right now is the refrigerator and the deep freezer and these lights. It's not a lot. Under 20 amps, Romex 12.2 can hold 20 amps of power, so no big deal. I just wire tied them all together. But then the ends of these down here, we're getting 15. So I called my electrician go-to guy, and he was like, well, 15 is a little high, but you probably get some, you know, I don't know, EMF, radiation jumping from one line to the other. He goes, 15's high, but, you know, it's nothing to worry about. I grounded my breaker box and came back over here and tested the ends of these cables. Mind you, they're just sitting on the ground and the breakers are off. They're not even turned on, and it went down to 3. So I'm like, okay, cool. And I'm like, 3 volts per line. It's just a little electromagnetic radiation jump from the lines being so close. That's why they use shielded line in aircraft and military stuff, so you don't have any of that jump over. But just that difference in that 15 volts down to 3 volts per every line, well, my batteries weren't really charging today in full sun. They were dropping. And I'm like, is it literally feeding that kind of power into the ground? Like, just straight into it? Well, originally, for anybody that's setting up these systems themselves and trying to make it home, I've learned a lot in 2 years, and I definitely recommend you just dive into it and don't be afraid. You definitely mess stuff up, but hopefully nothing major. And for a normal breaker box, I've basically felt like I've become an electrician. You want to bond this little screw here. I don't even want to touch this breaker box right now. I think it's energized. So that little green screw that comes in almost every breaker box was right here. And if you're getting normal split phase power for your house at your home, this screw gets bonded. And when that screw goes in, it screws the box to your negative line. It's called bonding. And then your negatives and your neutrals will be connected together. And then if you run a secondary line to a second box, you do not bond that. So I did that. Screwed that screw in right here. Used my multimeter to make sure they were connected. They were. So with all this power loss and energy, everything, reading the manual for this again, this 18 kilowatt 3-phase inverter, it automatically, if it's on inverter mode, will bond the neutral and the ground inside the inverter. And then if it gets generator / utility power, it breaks the bond and it'll separate them. So this was already bonded. I talked to some people on the DIY Facebook groups. They said, yeah, do not bond this. So I undid the screw, clearly thinking that if I undo the screw, it will break the bond. I have come to find out that it has not. So I'm going to go back and do some research and see if the screw, me and my stepdad were just talking, we were assuming that when you put that in and maybe it bends something, attaches something, but I took it out and it's still connectivity between that. Okay, great. Very interesting. So we're like, okay, we think we fixed the problem, why we're getting 120 volts to the ground in here. Now that 120 volts, with it bonded, where is it going? You know, if they're bonded and it's going, like, it goes straight to the ground. And the more I think about this, I was watching a physicist / electrical engineer, super smart guy on Dr. Greer. I don't know if you guys know him, the Disclosure Project. Talks about these UFOs and zero-point energy and all that stuff. And he says, yeah, our whole system is based upon electric circuits that are designed to lose power. They do it on purpose. So, and I'm like, now that I'm actually powering my own stuff, I can pay attention to the percentage of my batteries. I know how much is coming in. I know how much is going out. Like, why is there power just, you know, if these are bonded, if your neutral and your ground are bonded, which means they're basically connected the same wire, and you get 120 going into here, you know, you'll always get 120 when you test them. You know, go down to your house, put a multimeter on your 2 positives coming in. You have split phase power, 2 hots and a negative. I have 3 because it's 3 phase. And you'll get your 120. So, like, if it's bonded with the ground and it's going, how much money is the average household paying to send power straight down to the ground? I really don't know. So this is where it gets interesting. So with these, I have the neutral coming in, even though that's green. I had old military cable sitting around. It's for an air conditioning unit, Big Mac Daddy cable. Holds lots of amperage. And just hooked it up to, there's not going to be a lot of electricity in here. I hooked this up, so don't mind the colors. It's just the 3 hots. If you look up the colors for NATO, European Union, in America, the 3-phase lines are all different colors. It's a pain in the ass. So it's whatever wire you end up with. Unless you go to the store and buy it, I try to use what I have. So don't mind the colors, just the 3 phases. So it's coming in, 3 hots and a neutral. I do not have a grounding lug going outside anywhere to the ground. My inverter grounding lug is right here. It is not grounded. My DC batteries, there is no grounding lug. And my charge controller, it's not grounded. My solar panels are not grounded out there at all. So I think, where is all of my juice going? I really don't know. That's sort of why I'm making this video. I want to get some help. Up until the time I put the grounding rod in, or the bar, I put it, it's just a little thing just to see if it would fix the problem with the 15 volts on those lines down there, and took it down to 3. It did. So it fixed it, and I was just testing it. That's why it was hooked into the box. I was trying to troubleshoot things. And, but it's sucking a lot of juice out of my batteries. So now, for anybody that knows electricity, that is watching this video, I greatly appreciate your help. But right now, let me show you what's going on in here. You got the 4 wires coming in right here on their own, 20 amp breakers. There's nothing going to this one. Here they are, come down. My, you know, negatives in the neutral bar, grounds going over there to the grounding bar. Let's see if I can slide it over. Okay. So coming around there, they're doubled up. I don't know if that's a go or a no-go. I'm going to ask my electrician tomorrow. I assume it wasn't a big deal. I've seen a lot coming down here. Coming down here. Okay, 3 of these wires are sitting right here on the ground. Literally going to nothing. The other one is running up here and tied into this madness. I did have a breaker box right here. I'm sort of switching from these little inverters. And we expanded the house, making it bigger, yada, yada. So that's what we got going on. Now, for these wires, right here, sitting on the ground, running through the wall, this is where the confusion comes in, where I'm having some issues. Now, I can literally pull these breakers out of the box. Disconnected, disconnected, disconnected. These 3 breakers are out of the box. Mind you, this is bonded here, even though it's... Here, I'll just show you. Sorry, I'm holding my phone and doing stuff. Okay. Let me touch these together real quick. Okay. Let me see if I can do this with one hand. Okay, so you can see those are bonded. Actually, what I plan on doing tonight is cutting the power and coming in here and seeing, I would thought, undoing that green lug. For any electricians on here, I can't get a hold of my buddy at Sunday. I would think unscrewing that screw would break the neutral ground bond. Clearly, it is not on this box. So not only has it got a neutral ground bond here, it also has a neutral ground bond in the inverter. However, there is no ground going from there to there, so I don't know how it would bond it anyway. So, this is the question. We have 3 of these breakers hanging out of the box. Only one of them turned on, so the power is coming down. Coming down these onto the floor. And I'm going to set this multimeter down right next to it. Let me get it to volts. Alternating current volts. Here we go. Sorry, the camera's bouncing all over. So, I'm going to try to do this with one hand. 30 volts from going neutral to hot. Now look what hot to ground is. 10. And then neutral to ground, which is bonded over there in the box. You're basically on the same wire, you would think. Come on, help me out here. 46 going neutral to ground, and they're bonded in the box. And it's just going to the wall. It's not hooked up to anything. The black is literally hanging off the breaker over there. Not even hooked into the box at all. And why is the black in the red, or black in the neutral? Shit, I can't really see the number, sorry. So there, it's not touching. Like that. It's literally just sitting right there on the negative. And that's what I'm saying. I'm starting to even wonder if my multimeter, like, it's reading 4. Is there that much power jumping? Like, I'm not even touching these lines and it's moving. Anyway, going to the black line. Off the black line, on the black, 30 volts. Okay, neutral to ground. Look at that. Neutral to ground right there. 46 volts. It just doesn't make sense to me. I've been talking to my stepdad. He works on aircraft, and, you know, a little bit different. He's, you know, it's funny. You talk to, like, an electrician that does commercial and household stuff. You don't really know much about DC. You know, everybody sort of has their specialty, and when it comes to solar, you sort of have to learn it all. But for anybody out there that watches this video, if you don't know and you have some buddies that have set up systems, you know, send them the video. You know, see if they can comment, see if they can help, because these breakers are not even in the box. I mean, is that much voltage? The only thing I can think of is that much voltage is jumping from the line to line. You know, it just seems like a lot to me. It seems like a lot. But that's where we're at. I've been in this house 2 hours trying to figure this out. It's time to call it a day. Go back, get some food, and start over tomorrow. But for anybody that can help, I greatly appreciate it. Peace out.